Here are my solutions. In the exercise number 1, we want to predict the type of motion. The longest link is 7, the shortest is 2, and the two others are 4 and 6. L plus S is 9 and P plus Q is 10. So L plus S is less than P plus Q, and the shortest is a side link, which is the driver in this case. Therefore, we expect a crank rocker motion. In the second exercise, the longest is 7, the shortest is 2, and the two others are 4 and 6. So L plus S, which is 9, is less than P plus Q being 10, and since the shortest being 2 is the coupler link, we expect a rocker-rocker motion. In the third exercise, we want to find the range for the driver link to provide a crank rocker motion. Considering the 4 conditions for the existence of the linkage, the driver link is required to be less than or at most equal to 17. Now let's check the Grashof's condition for a crank rocker motion, which says L plus S must be less than or equal to P plus Q, and the shortest should be the driver. The driver is X, and for being the shortest, it should be 4 unit lengths or less. And considering X as the shortest here, this condition ends to X must be shorter than or equal to 3. The intersection of the two Grashof's conditions becomes X must be 3 unit lengths or less. Finally, we need to take intersection from this and the requirement for the existence of the linkage, which becomes X must be less than or equal to 3. In the exercise number 4, we need the follower link for a crank-crank motion. For the existence of the linkage, the follower link should not be more than 12 unit lengths. In order to provide a crank-crank motion, we need to keep the base as the shortest link. This means that all other links, including the follower, should not be shorter than 2 unit lengths. So X should be longer than or at least equal to 2. This is one condition, and the other one says L plus S must be less than or equal to P plus Q. For that, we need to make 3 different assumptions. If X is the shortest, the longest, or either of P or Q. If X is the shortest, it can only be 2 unit lengths. But apart from that, considering X as the shortest here yields X must be 0 or less. So the intersection of this case is empty. Next, if X is the longest, meaning even longer than 6, from Grashof's condition it should be less than 8. And the condition for keeping the base as the shortest is always considered. You see here, here, and here. So in this case, X must be between 6 and 8. Lastly, if X is either of P or Q, meaning that it should be between 2 and 6, from the Grashof's condition it must be more than 4. So between 2 and 6, but more than 4, means between 4 and 6, and something between 4 and 6 is of course more than 2. Finally, the union of all cases, between 4 and 6 or between 6 and 8. Means between 4 and 8. And something between 4 and 8 is definitely less than 12, which satisfies the existence requirement. In the next exercise, we need the coupler link for a rocker-rocker motion. As usual, we check for the existence, which says the coupler cannot be more than 17 unit lengths. For a rocker-rocker motion, we know that there are 2 situations to provide it, and we need to take a union of the results from the 2 parts. The first part says the shortest link must be the coupler, which is our X, so it should be 4 unit lengths or less. For the Grashof's condition, the good news is the only possibility for x is to be the shortest. So we need to check only one case, which yields x less than 3. And something less than 3 is definitely also less than 4. Let's skip the results of the first part and go for the second part. Part 2 says L plus S must be greater than P plus Q. The bad news is all the possibilities for X are open. It can be the shortest, the longest, and either of P or Q. And we take a union of the results of all cases, which ends to X between 3 and 5 or more than 9. Now it's time to take a union from the results of the two parts. The union of x less than 3 and x between 3 and 5 becomes x just less than 5. And x more than 9 is also included. So for a rocker-rocker motion, x must be either less than 5 or more than 9. But not any value more than 9, because it should be less than 17 to satisfy the requirement for the existence of the linkage. In the exercise number 6, we want the range for the length of the coupler link for a crank rocker motion. The requirement for the existence of the linkage yield the coupler cannot be more than 12. For a crank rocker motion, the shortest link must be the driver, which is 2 unit lengths. So any other link, including the coupler, cannot be shorter than 2. For applying L plus S less than P plus Q, we need to check 3 cases. If the coupler is the shortest, the longest, or either of P or Q. For each case, we solve the inequality for X and take the intersection of all the requirements. This one is empty, this one between 6 and 8, and this one between 4 and 6. The union of all cases becomes X between 4 and 8. So for a crank rocker motion, the coupler needs to be between 4 and 8, which also satisfies the requirement for the existence of the linkage, because something between 4 and 8 is of course less than 12. In the last exercise, we need the range for the base link to design a rocker-rocker motion. For the existence of the linkage, the base link cannot be more than 12 unit lengths. For a rocker-rocker motion, we need to check both of the two situations and then take a union. For the first part, one of the requirements says the shortest link should be the coupler. As you see, the coupler is not the shortest, since we have the driver as 3 and the follower as 4 unit lengths. So the range for the first part is empty. Let's check the second part, which says L plus S must be greater than P plus Q. We need to check all the possibilities for the base link, if it is the shortest, the longest, or either of P or Q. In each case, we solve the system of inequalities for X. Then we take a union of all cases of part 2. Finally, we take a union of the results from the two parts, which says X between 2 and 4 or more than 6. But not any value more than 6, since it should be less than 12 to respect the need for the existence of the linkage. This concludes this lecture, and I just remind you that you can download a PDF version of these solutions from the resources of this lecture.